Yeah, thank you. Welcome to my little presentation. I'm your last obstacle before the break for lunch, so hopefully you have enough power to stand this 10-20 minutes with my presentation. I will tell you something about monitoring in the industry, in the automotive industry, and what was the challenge our customers bring to us. And I'm taking you today to a factory of an automotive supplier. Here, plastic parts for the automotive industry are manufactured, and you've probably had a storage compartment or a ventilation module in your car. You have touched already, and that comes perhaps from this place. As you can imagine, I cannot show you a picture of the factory itself because it's important to be a little bit secret in this business. So unfortunately, this looks the factory like a little bit. We have robots, we have assembly lines, we have production equipment. The prices are calculated very tightly in the automotive industry, and the operation can only be profitable if all machines run all around the clock. The worst thing that ever can happen is a machine shutdown, whether due to equipment failure or operator errors. A nightmare for the production manager. In this case, every minute downtime costs a lot of money, is burned and must be avoided at all costs. As their partner for digitalization, we ensure to reduce this downtime as little as possible. So, how did we achieve this? First and foremost, we improved transparency in the production process. We use sensors to measure ambient temperature and humidity. We regularly checked the oil lubrication levels and monitored the 14-meter-long production line with a leakage sensor. A detection cable was along the whole production line under 15 meters and detects oil leaks at any point. In clean room operations, maintaining air as particle-free as possible is a crucial factor. Contaminating from doors being open too long must be avoided at all costs. A magnetic door contact measures the number and duration of door openings. A people counter monitors the number of individuals in space. Finally, a dust sensor regularly checks the dust particle levels. With the moving parts of the production equipment, vibrations and excessive movements indicate anomalies and wear. Sensitive sensors for vibration, which measure movement, acceleration, and vibration on the X, Y, and Z axis, are used to monitor robotic arms and press machines. And guess what? The reason why we love LoRaWAN so much is that we can combine devices from different manufacturers freely. The ecosystem is so rich, and we can find the perfect sensor for every single task. It's as simple as playing with Lego. And then we take the data and display it on a clearly structured data board. Latest measurements from temperature, door openings, oil levels, leaks, vibrations, people counting, fine dust particles. Numbers, data tables, and graphical trend curves. But somehow, it's still difficult to quickly identify the important information that is relevant for a smooth production. Too much data and too much numbers, and it takes time to find the crucial information. So what's the solution? We aggregate the data into a useful information. From huge flood of data, it's only often important to have certain measurements which reach or exceed specific thresholds. For example, it doesn't matter if the temperature is 18, 20, or 24 degrees. But if the temperature rises above 27 degrees, it's critical for the raw materials which are used, and countermeasures must be taken. We condense the data to alerts. To do this, we use color highlighting on the dashboard. Critical measurements are marked bright red to draw the user's attention to important values. Here, for example, the clean room door is open. But what if no one is looking at the dashboard at the moment to notice the emergency? That's why we take a step further and actively send alerts, notifications when critical values are reached to the responsible personnel. Depending on the urgency, we send an email or an SMS to their smartphone. So for example, for room climate monitoring, we send an email. The leakage gets an email plus an SMS for quick notification, the oil tank level as well, and the door opening if it's opened more than 15 seconds. However, there are some production steps where it's not economical to monitor with sensors. A significant time loss often occurs when employees need assistance from a colleague and have to call them. Where is the colleague? Where is the next phone which I can use? And that's the reason why, because language barriers within international workforce also make quick communication difficult. To solve this, we installed button boards on 10 machines. With 3 different colored buttons, employees can quickly request support calls for specific tasks. This button briefly lights up when pressed and provides an immediate user feedback. The installation was extremely easy. We just glue it with an adhesive pad. And of course, we display individual alerts on a dashboard to make the alert visible. And we send to the corresponding employee an email for intermediate informing. So, however, since employees are not always in front of their workstations and often moving around in the production floor, we send an additional notification.
Attention. Need for support. Machine 651 urgently needs your support.
So I'm not sure if you can hear it clearly. We had a short test on the plant, and it became clear that an SMS on a smartphone is not noticed in such noisy environments. So now we use a text-to-speech gateway and generate a phone call where the computer voices inform the employee about the service request. The employee's phone will keep ringing until they answer the call and they are properly informed. So what's the effort for all of these benefits? First of all, we have easy network coverage. We ensure that coverage for the full reception of sensor data in the production hall with a single indoor gateway. We mounted it centrally in the middle of the hall under the roof, and it receives data from all the installed 25 devices on that plant. And then for the various measurement tasks, we selected the appropriate devices from different LoRaWAN manufacturers. Here we easily combine different providers to ensure the best performance for our client. The financial investment for the client is highly economical. The hardware costs are roughly about 11,000 euro for 25 devices, and the client expects savings of 200,000 euro for better quality and the prevention of downtime and maintenance work. And as always, the installation of the devices was very easy. The sensors for door openings and temperature measurement were simply glued in place and have a very easy installation process. So here you see the 2 parts of the door opening sensor, and it's responding very quickly. In 1 second, you get the notification if the door is open. You see the green flashlight at this video clip. The oil level sensor was just screwed on the tank, And the vibration sensors we always also use were quickly attached using magnetic base plate. We also quickly installed the button boards at the workstations using adhesive pads. Yes, what's the benefit? So after a short period of operation, our customer expressed a great satisfaction, and that's very, very nice for us. And that is the way they gain information from our measures. First of all, they know the condition of their machines and get improved transparency. They avoid downtime and increase productivity. They improve the communication and response time for support requests and can now solve problems very much faster and continue the production. In summary, they optimize the performance in their production. But what get they as an extra bonus? We analyze the digital data from the push buttons and generate a report on the timing and number of support requests. Where are many requests? Are there specific machines involved, or are there peaks at certain times? All this we aggregate and generate a report to optimize the production. So what is my advice tip for you? What can I share to you from this use case? First of all, collect data. Without data, you cannot make any decision. Compress the large amounts of data into a few key pieces of information. Then deliver the information exactly where it's needed, quickly and precisely. And do it proactively, so no one has to search for the information and gets it instant. So what's next? Of course, we are planning now to do even better data analysis, not just real-time alerting, but with AI, we aim to develop a forecast and predict future events to do more predictive maintenance. But this will be the topic for another presentation. Maybe next year I can show you how the story continues. For now, I say thanks for your attention and enjoy your lunch.